Now let's carry on. Oops, that was too fast. Now, that's loud. To insert data, right? When we're adding data to a table, we're adding an entire row, right? The entire record. So in some cases, you might be adding just one record, but in other cases, you might have multiple records. Think of a new team member who is starting or a new employee who is starting a job. You will just have to add one, but if you have a host of them, you don't need to add one each time. You could have a bunch of them separated by commas. And in some cases, you might need to populate all the columns in the row. In other cases, you might have to specify what columns you need to in the row. Let's take a quick example on the left here. You see we are inserting into the promotion table from the sales schema. And we're specifying that we're going to insert these values. The clearance sale, that's a variable character, the date, the amount, the percentage maybe, and then a note, 10% discount. So all of these are going to be inserted to all the columns because we have not specified. Okay, so this will be inserting one record to all columns in this table. In other words, in other cases, you might want to specify the columns. We need to insert just the promotion name, the product model number, and the discount. In that case, this first variable character, which says caps lock, is going to be inserted into the promotion name column. The number 2 is going to be inserted in the product model ID number, and the number 0.2 is going to be inserted in the discount column. So you might be able to specify your columns, or you can insert to all the columns. Now, that's the general gist of how you insert data into a column. But there are 3 different ways you might insert data into a column, right? First, you can insert the data manually using insert into, just like you've seen here, insert into, and the values, you enter the values manually. In most cases, you might want to insert into using the insert into and select statement. We talked about the select clause earlier. In this case, we already have our data existing in another table, so you automatically insert it rather than type it manually in this case, which will avoid you to have errors. For instance, one team might send you a spreadsheet with all the new employees that need to be added to your database. You can create a table with that Excel spreadsheet, or you might have another table that you want to extract information from. Maybe you have customers table, but you want just customers in Texas. So you might go ahead and say insert into your new table, Texas customers, and then you select from your customer table and specify if you have a word clause or predicate. So in that case, you're inserting into an existing table from another existing table. The final case is when you have, oops, I don't know why this is showing, I can't see it clearly at the bottom, but that's fine. The final case is when you have to create the table on the fly automatically, okay? So for instance, I again want to grab just customers in California, then I'll have to say select into. Be very careful this doesn't confuse you with insert into. When you use select into, the new table gets created on the fly. So I'll write select into California table or California customers from my customers table where the customers are from California. Maybe I'll use zip codes and so on and so forth, or maybe just the state code. All right. So those are the 3 different ways again. First, inserting it manually, as we see right here on the screen. Next, inserting it from an existing table to another existing table. And finally, creating a new table on the fly. Okay, examples of when you might want to do that again. Let's say you're creating a backup offer table. You might say at the end of the day, I want to just grab everything from this table and move it over to another table. You might also move it over to another database altogether, as we pointed out the differences between tables, databases, schemas, servers, and so on. So remember, that's useful if you need to create a backup or you need to create just a copy of a table. All right, so that's about inserting data into a table. Next up, let's talk about how we deal with automatically generated values. So automatically generated values could be of two types. The first type is identity properties. When you hear the word property in this case, I want you to think about characteristics. What are the properties of a living thing? What are the characteristics of a living thing? What are the attributes of a living thing? So think about the identity property is the column or the attributes or the characteristics of a particular record in a table. So identity property will refer to a column. It's bound to a column. It's usually a whole number. For instance, a student table is going to have student ID. In that student ID, we have a seed. We decide what number the student ID should start with. You can say your student ID should start from 1000, and then you can say increase it by 1 or by 2 or by 3 or by 10 or by 50. It's up to you. And well, not really up to you, up to whoever designed the database or designed that table to say, I want my identity to start from 1. I want it to increase by 1. Make life easy for me. If you need to check out what your identity scope is, you can use the select scope identity. You should have your database should give you what value, or you could select identity of the current in that table. As you can see on the top left right here, it says select ident underscore current. So we're going to see what the current ID is for the promotion table in our sales database. All right, or sorry, in our sales schema. Now the next step, well, very important to note is automatically these numbers are generated from the database engine. We don't get to specify each time we're adding a column. So if you're inserting a record, when you insert that record, the ID field gets automatically added for you. All right. Now, a sequence object is a different type of automatic value. This is not tied to just a table. There are some times that you might want multiple tables to have the same number that you can keep track of. If you want to have the same number in multiple tables or multiple objects, then you use a sequence, because the sequence is bound to the schema. It's not bound to the column. The column is in the table, identity is bound to just that column, but the schema is bound to the object. So you can use your schema, or rather you can use your sequence to create a number that you can track on multiple tables. But just like the identity, the schema, or sorry, the sequence, I keep saying schema, the sequence has a seed and an increment. So you can also decide, let my sequence start from number 0 and increase by 10. So you have 0, 10, 20, 30, 40, and so on. Or make life easy for you, start from 1, increase by 1, and then you can keep track of it. When you need to create a sequence, you create one on demand. Just like you see in this example here, we create a sequence and call it invoice number. We're going to give it a data type of integer. Again, it has to be a whole number. We're going to start our invoice number from 1000, and it's going to increase by 1 each time. So when we go ahead and need to create an invoice for a reseller, which you see in the next example, we go ahead and insert into the sales schema, the reseller invoice table. We're going to insert these values. It's going to pull the next value from our invoice sequence that we created earlier, and it's going to add also a value for the next column of that table, because this will be the ID column, that will be the next column, and so on and so forth. Probably get the current date and enter the value of the item that was sold and the amount that it was sold for. All right. So that's how you automatically generate this invoice number. If you need to get the invoice number, again, you just go ahead and select it, just like similar to what we just did with the identity property. So that gets us going. And we'll see a lot of these examples when we actually perform the lab for today. But third thing I want to talk about, we started with inserting data. Second was talking about automatic value. The third is updating data. In this case, the data already exists in our table, but we want to change it. We already added the employee, for instance, or we added a student to the table, but the student has an additional information that needs to be updated. Maybe we spelled the name wrong, or we had the wrong date of birth. So in order for us to do that, we need to change the existing data in that table. Very, very important is remember the importance of your where clause. If you don't add a where clause, that change is going to affect every record in your table. So it's always advisable to start with your where clause. When you start with your where clause, then you can actually remember that you did not forget the condition. Better yet, you might want to test that script by using a simple select statement. Let's take, for instance, the example we see here. We're going to update the promotion. We're going to set the notes to 25% off for socks, but we only want to change that where the promotion ID is 2. If we forget this where clause, we are going to end up changing the records for every single item in the promotion table, which is going to give us a lot of headache. So we don't want that. What we want to do is, for instance, personally, I'll start by using a select statement to say select all the records, select star from sales promotion where production ID is 2. When I see the output, then I remember, okay, this is the particular record that I need to effect changes on. Then I can go ahead and write my update statement, set the notes that need to be changed, and add the where clause, which is the most important part. Again, similar to inserting data, there are multiple ways you can update data. You can update it manually, right? By using update set, just like we see in the example. When you use update, you specify the table that needs to be updated. You use set, you specify the column or columns, because you can update one column or you can update multiple columns. You just use commas. And once you do that, you then write the name of the column and the new value that needs to be updated. So you can update all records, again, if you forget the where clause, or you can update just a particular record that is actually satisfying the condition in your where clause. All right. Now, another way that you can do updates, which is better because it's automatic, it's not manual, is by using update set and from, as you see in this example right here. Okay. In this example at the bottom, you're updating a promotion, you're setting the notes to you format it to be equal to P plus off plus that. So it's going to get a particular discount in percentage. The discount, maybe it's 10, 20, 30%. So it's going to do that in percentage off for a particular name. But you're not specifying it manually. You're getting it from another table. That table you're getting it from is the product model table, and it's coming from the product schema. So you have your sales schema, you have your product schema, where you're pulling data from the product model table, and then you're going to check where the notes are empty. If the note is empty, and then the product model in your sales promotion table matches the product model ID in your product model table, then go ahead and make the change. So again, word of caution, you might want to use a select clause or a select statement to make sure that everything outlines as you expect before you make this change, because once you make the change, it will be a lot tedious for you to go back and revert it. Okay. So once again, two ways of updating data. Manually, you can update it using update set clause, update one column or update multiple columns, as you see in the second example. You're updating the discount column and also updating the notes column. Okay, so discount column, in this case, you're setting it to 0.2, and the notes, you're going to replace whatever notes you had that had 10%, you're going to replace it with 20%. All right, so that's how you go ahead and update data. Very important. Once again, remember your where clause. All right, let's jump into the next section, which is deleting data. Deleting data, again, also very important to have that where clause in there. Otherwise, you'll be deleting everything on the table, and that's not going to be very good for your team. Some people might be giving you some nasty phone calls that you might get yourself in a tense moment. But deleting record does not mean you're deleting a column. You're deleting everything from the row. Every single column gets deleted. You cannot decide and say delete this column, leave that column. No, everything in the row goes. So to do that, you use your delete clause and a from or delete from clause and specify the name of the column of the table. For instance, a product table in the production schema. Here we want to only delete the records where discontinued is equal to 1. If you forget this where clause, you're going to end up deleting every single product. All right. So again, all records are used in this case, and remember, all columns are deleted. Now it's important to note that I think this is a mistake. I should say, one row or multiple rows. All right. It's important to note that there is an alternative of deleting everything in your database, or rather in your table. If you need to delete everything from the table, the better way of doing that is using a truncate clause. In a truncate clause, the where clause is not accepted, so everything gets wiped out. It deletes all the rows, right? It's more efficient than using a delete from. Imagine if you have to delete 1,000,000 records, it's better to just truncate the database. The difference here is the truncate is actually going to lock the entire table. Meanwhile, delete is going to lock just the rows that you're currently deleting. So it depends how you want to do it. Also, when you truncate it, you're not able to revert that operation. Now, to explain again the difference between delete and truncate. If you're trying to bake, let's say, some cupcakes, you have 12 cupcakes, deleting would mean, if you made a mistake with one of the cupcakes, you remove just that one cupcake and replace it with something else, or remove it altogether. But if you're truncating it, you're getting rid of all 12 cupcakes in your rack and then starting afresh. But the cake pan still remains available, which means the structure of your table is still there. Your structure of your table is still there. You can still reuse it. So delete is different from truncate. Delete takes out just particular rows that meet a condition. Truncate wipes out everything. But there's a third option, which is not what we're talking about here, is dropping. When you drop, you're dropping the entire table, both the data and the structure. So you don't get that structure again. If you have to start again, you have to start creating those columns and then inserting your data into it. All right. Just wanted to point those differences out. So merging, what's the importance? You might need to synchronize multiple tables, say, or joining two tables all together to give you a particular result. And depending on the case in point, the normal syntax would be, you're merging into, you specify the name of the schema and the name of the table for a target table, or give it an alias of target table. Now you select, or you use the using keyword per se. I know it sounds cheeky, but now you select what columns you need to merge from your source to your table or to your target table. but you need to also specify what is the common column between the source and the target table. Once you specify those, you can then say, hey, when these two of them are matched, you should go ahead and update whatever you want in your target table from your source table. If the two of them are not matched, for instance, say the target has 1 and the source has 2, then go ahead and insert the column with the particular values from your source table. But when there's no match by the source table, then delete it. So whatever is in the target table that's not in the source table, delete it. Whatever is in the source table that's not in the target table, insert it. Whatever is in both of them, just go ahead and update it with what you have in the source table. So that's how you can set a merge sequence to insert rows, update rows, or delete rows based on the matching values from the source and the target tables. And you can see clearly here in this example, it specifies that in your invoice, we want to update it using the invoice from the staging environment. And we're making sure that the sales order ID in the staging environment matches the sales order ID of the invoice. So when there is a match, go ahead and populate the customer ID, the order date, the purchase number, and the total due. When there is no match, then go ahead and insert these values to these columns. So the values are coming from the source table, the staging table, and going into the target table, sales order, customer ID, and so on and so forth. All right. So that's how you go ahead and proceed with that. That's it. It's not that tedious. Again, changing data. We just had to talk about inserting, updating, and deleting data, also merging them. So in our lab activity, which I'll do in a separate video, we're going to use the insert into to manually insert data. We use some default and null values to be able to skip those columns that are not required within the row. And also in another example, we'll explicitly insert into particular columns and not all columns in the database. Next up, we'll also update data manually and update it from an existing table. And finally, we're going to use the delete and the truncate statements. That's it. Some of the challenges that I'll give you. Again, this is a view of what our entity relationship diagram looks like, the different tables in our environment, talking about the address, customer products, product description tables. This is the schema that we'll be using to practice our challenges. And some of the challenges would be inserting a product, inserting a new category with 2 products, and writing a query to insert a new product category, and so on. We will also go ahead and update products as well as delete products. Those should be straightforward, but the key here is practice, 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 because practice makes perfect. Now, quick recap on what we've covered today. We talked about how do we change data, how do we modify data in a table. We modify data by inserting data into the table manually or automatically if it exists already. We could also generate automatic values, which might be bound to a column like a property, or in this case, an identity, or which may be bound to a schema, in this case, a sequence. We finally talked about updating and deleting data, again, manually, on how it's important to remember the where clause and its significance. And finally, we did talk about merging data based on multiple tables, a source table and target table, synchronizing the data. And hopefully that was helpful. And if you have any questions, feel free to reach out to me. I really appreciate your time together, and thank you for listening to this. And